Hey everyone, and welcome back to the channel. Today, we're taking a deep dive into a true titan of the programming world, a language that has shaped modern computing in more ways than you can imagine. We're talking about C. So, what exactly is C? It's not just another programming language. It's a foundational pillar upon which much of our digital world is built. To really understand C, we need to travel back in time to the early 1970s. To a legendary place called Bell Labs. There, a brilliant computer scientist named Dennis Ritchie was working on the new Unix operating system. He needed a language that was efficient, powerful, and portable. The existing languages just weren't cutting it. So, building upon a language called B, Ritchie created C. The primary goal was to write an operating system, and it succeeded spectacularly. The Unix kernel was rewritten in C, a revolutionary move that demonstrated C's power and flexibility. This synergy between C and Unix catapulted both into stardom, making them the standard for academic and industrial development for decades to come. Now, let's get into the nitty-gritty. What makes C so special and sometimes so infamous? Two words: pointers and memory management. This is where C gives you unparalleled power. A pointer is essentially a variable that stores the memory address of another variable. Instead of working with data directly, you're working with its location in memory. This allows for incredibly efficient data manipulation, dynamic memory allocation, and the creation of complex data structures like linked lists, trees, and graphs. With this power comes great responsibility. C gives you direct access to memory through functions like malloc to allocate memory and free to release it. You, the programmer, are in complete control. This is a double-edged sword. If you manage memory perfectly, your program will be lightning fast. But if you forget to free memory you've allocated, you get memory leaks, which can slow down or even crash your system over time. Or worse, you might access memory you shouldn't, leading to security vulnerabilities and unpredictable behavior. This manual control is what makes C both a high-performance tool and a challenging language to master. There's no garbage collector holding your hand like in Java or Python. You are the master of the machine's memory. This low-level control is precisely why C is synonymous with performance. When you compile a C program, it's translated into machine code that's incredibly close to what the processor actually executes. There's very little overhead. No virtual machine, no just-in-time compilation. It's just raw, unadulterated speed. This is why C has been the language of choice for performance-critical applications for nearly 50 years. Think about the software that needs to be as fast as humanly possible. Operating system kernels like Linux and Windows. Device drivers that communicate directly with hardware-embedded systems in your car or microwave, and high-performance computing for scientific simulations. Even the core engines of many games are written in C or its successor, C++, to squeeze out every last drop of performance from the hardware. If you've ever wondered how your computer boots up so quickly, or how a game renders complex graphics in real time, you have C to thank for much of that speed. The influence of C cannot be overstated. It's not just about the systems written in it, it's about the languages it inspired. C's syntax, the curly braces, the semicolons, the control structures like if, else, for, and while became the blueprint for countless other languages. If you know C, you'll see its reflection everywhere. A C++ started as C with classes, adding object-oriented features directly on top of C. Java and C# borrowed the syntax heavily. Even though they operate in a completely different paradigm, with virtual machines and automatic memory management. Even modern scripting languages like JavaScript and PHP share that familiar C-style syntax. Learning C is like learning the Latin of programming languages. It gives you a fundamental understanding that makes learning many other languages much easier. It's the common ancestor, the lingua franca, that connects a vast family of programming languages. So, in an age of Python, JavaScript, and Rust, is C still relevant? The answer is an emphatic yes. It is not the language you'd typically choose to build a modern web application or a simple mobile app. There are better, safer, and faster tools for those jobs. But C's domain remains unchallenged in areas where performance and direct hardware control are non-negotiable. Every time you use your smartphone, your computer, or even your smart TV, you are interacting with countless lines of C code running deep within the system. The Internet of Things, or IoT, is a massive and growing field where tiny resource-constrained devices need to run efficient code, and C is a perfect fit. Furthermore, understanding C provides a deeper appreciation for how computers actually work. It forces you to think about memory layouts, data alignment, and the call stack. It's a foundational skill that separates a good programmer from a great one. It gives you a mental model of the machine that is invaluable, regardless of what language you use day to day. So, should you learn C today? If you're serious about computer science, if you want to work on operating systems, embedded systems, or performance-critical software, then absolutely, it'll be challenging. You will struggle with pointers. You will spend hours debugging segmentation faults. But the journey is incredibly rewarding. It will make you a more disciplined and knowledgeable programmer. C is more than just a language. It's a direct line to the heart of the machine. It's a testament to the power of simplicity, efficiency, and giving the programmer ultimate control. It has stood the test of time, and its legacy continues to power the technology that defines our world. Thank you so much for joining me on this deep dive into the C programming language. I hope you found it as fascinating as I do. If you enjoyed this video, please hit that like button, subscribe for more content on the history and technology of computing, and let me know in the comments what language you'd like to see me cover next. Until next time, happy coding!